All right, let's get right into it. If you've ever built anything with React, you know that amazing feeling when you get a prototype up and running. But what happens when that little prototype needs to grow up? Well, today, we're going to pull back the curtain on the architectural patterns that let you take a React app from just a few components to a massive enterprise-level beast. Man, this one hits home, right? It's that exact moment when your beautiful, simple code starts to feel, well, messy. A tangled web of props, state, and logic you've copied and pasted all over the place. That's the scaling wall. And trust me, every single developer hits it at some point. So yeah, how do they do it? What's the secret sauce that lets the pros build apps with millions of lines of code? Here's a hint. It's not about just writing more code. It's about writing smarter code. It's about having a blueprint. And that blueprint is built on a handful of really solid design patterns. And look, this isn't just some academic theory. The patterns we're about to walk through are battle-tested. They're used every single day by the biggest names out there: Facebook, Airbnb, Netflix. The very teams that built React and pushed it to its absolute limits rely on these ideas to keep their codebases from turning into chaos. So, who's this for? Is this for you? Well, if you're a front-end lead trying to scale a big dashboard or a SaaS app, yup. If you're a developer who is just sick and tired of prop drilling, passing a prop down 10 levels, oh yeah, this is for you. And if your team is trying to build a UI that's still a joy to work on when you hit component number 100, you're in exactly the right place. Okay, first things first, we have to start with the absolute foundation. This is the one pattern that so much of modern React is built on: separating your logic from your UI. The easiest way to think about it is the brains versus the looks. On one side, you've got your container component. This is the brain of the operation. It's the smart one. It worries about all the heavy lifting, fetching data, managing state, all that business logic. And then you have the presentational component. Its only job is to look pretty. It just takes in props and spits out some UI. It's dumb, and that's what makes it so powerful. So here's what one of those smart containers looks like in the wild. Our user list container here is the brain. You can see it's using useState to manage the list of users, and it's using useEffect to go and fetch that data when it first loads. But notice what it's not doing? It's not rendering any fancy divs or styles. It just does the work and then passes the user's data down to the dumb user list component. This separation makes everything so much cleaner and way easier to test. All right, so once you've split your logic and UI, the next big problem comes up pretty fast. How do you reuse all that great logic? This next section is kind of a fun journey through how the React community tried to solve this exact problem. So the community went on this big quest for the perfect way to share logic. And it led to these three really clever, really powerful patterns: higher order components, or HOCs for short, then came render props, and finally, compound components. Each one was a different attempt to crack the same nut. First up, the higher order component. Now, the name sounds a little intimidating, but the idea is actually pretty simple. It's just a function that takes your component as an input, wraps it up, and gives it some new superpowers, like checking if a user is logged in before showing a page. And here's what that looks like. This withAuth function is our HOC. It takes any component you give it and spits out a new one. All it does is check if the user is authenticated. If they are, great, it renders your original component. If not, it redirects them to the login page. It's like a reusable security guard for any part of your app. Next up in the evolution, the render props pattern. This one's a little different. Instead of wrapping your component from the outside, it gives you a special prop, and the value of that prop is a function. It's like handing a component a set of instructions for what to do with the data it manages. It sounds weird, but it's incredibly flexible. Check out this example. We have a data provider component, and its magic is that render prop. See how we're not just passing in a value, we're passing it a whole function that takes some data and tells the component exactly what to render. In this case, an H1 tag. The data provider handles all the logic, then calls our function to do the UI part. This gives you complete control. And that brings us to compound components. Honestly, the best way to understand this is to think about the plain old HTML select and option tags. They look like two separate things, but behind the scenes, they're secretly working together. They share state and logic to create one seamless experience. This pattern just feels like magic when you use it. You get this pre-packaged component kit. Look at this tabs component. As a developer, you just put tabs.tab inside of tabs. You don't have to manually pass around props like active tab or hook up on tab click handlers. All of that is managed for you under the hood. It creates this beautifully clean API that's just a dream to work with. So you have HOCs, render props, compound components. They're all super powerful, but they can also be, well, kind of complex. The React team saw this and thought, there has to be a simpler way. And that thought process led us to the modern winner. What if you didn't need all the wrappers and special props and hidden magic? What if sharing powerful, stateful logic was literally as easy as just calling a function? And here it is. Enter the custom hook. Let's look at this useFetch function. It's just a normal JavaScript function that starts with the word use. Inside, it can use other hooks like useState and useEffect to manage its own state and logic. And then it just returns whatever you need. Now, any component in our app can get data just by calling const data equals useFetch some URL. It's simple, it's direct, it's amazing. And that's why, for almost every use case for sharing logic today, the custom hook is the modern winner. It takes all the best ideas from the patterns that came before it and boils them down into a beautifully simple API. Hands down. So we've gone on quite a journey here, from containers all the way to custom hooks. But let's bring it all home. Why does any of this actually matter for you and your projects? What can you do with this information first thing Monday morning? Well, it matters for 3 big reasons. First, scalability. These patterns are what let you grow from 5 components to 500 without your codebase collapsing into a mess. Second, DRY, which stands for don't repeat yourself. You write that useFetch hook once, and then you use it everywhere. And finally, testability. It becomes so much easier to test your app. You can test your dumb UI components completely separately from your logic. This is how you build apps that are solid and dependable. We've covered a lot, and it can feel like a lot to take in, but you don't need to go and refactor your entire app tomorrow. Just pick one thing. Look at your code on Monday and ask yourself, what's my biggest pain point? Is there one giant component you can split up, or some logic you've copied 3 times that could become a custom hook? Pick one. That's your first step, and that's how you start building for scale.